Good morning, everyone. This is Sayed Hadi Hussain Shah. I work here as a research scientist with Power China Huadong Engineering Corporation, particularly on Al Hanakia 1100 megawatt solar independent power plant. I am here to present my work with your conference. The title of my paper is Integrated UAV Imagery and Hybrid Metrics for PV Degradation Analysis. And here are my colleagues. We work together. Mr. Liu Guanghua, he's a project manager here. Then I myself, then Mr. Amjad Ali, and Amir Al Ahmad, Afan Muhammad Khan, and Ghulam Mustafa Abdo from KFUPM. So let's start. First of all, introduction. So abundant solar resources. The countries like Saudi Arabia has a high potential of solar energy because there are very high radiations and availability of solar for most of the year make it significant and ideal site basically for uh, high efficiency or maybe for a higher generation of solar energy. So basically, energy diversification reduces dependence on oil and enhances the energy security, particularly inside Saudi Arabia, where almost more than 80% of the electricity has been generated via what we can say oil. So it is also very beneficial for the environment because when you install solar panels it has zero carbon emission, so it also supports the sustainable development goals of United Nations, that is affordable and clean energy. And yes, of course, the price of solar power is very less and very cheap as compared to that of uh, oil based generation if we calculate per watt. So why Saudi Arabia needs to install? Because their Vision 2030 alignment, the key role of solar panels are there, and the large scale solar power projects inside uh, Saudi. It's a part of Vision 2030. So this is the basic introduction of our paper. So now the impact of harsh environment conditions on PV efficiency. You see, high temperature lowers the voltage, reduces the efficiency. It is very obvious that when the temperature rises at certain level, then the voltage level drops significantly. And secondly, the dust and sand. Inside the Saudi Arabia, there is a major flaw, what we can say, of sandstorms. You will find a regular sandstorm after almost every day. So due to sandstorms, the efficiency or the output of solar uh, panel drastically decreases due to blockage of sunlight. Then there comes the humidity, because in our study we also saw some corrosion and that decreased the output. After that, extreme weather conditions obviously damages the panel or the performance, maybe due to rain, due to cloud, due to storm. These all combined together called the extreme condition. And UV exposure, the ultraviolet radiations inside these areas are very much high, and that causes the damage of material, and the material damage is again causes the efficiency reduction. So, what are the main objectives of our study? So, first of all, evaluate long term degradation of PV panels. Being a research scientist in Power China, it's our aim because we are currently installing many power projects inside Saudi Arabia, more than 10 to 12 projects currently we are having, and that consists of 2 gigawatts, 1.2 gigawatts, it's in gigawatts basically. So consider before this we have not installed the solar projects inside the kingdom. So that's why it's very important for us to what we can say, to analyze that how much of the time one solar project could last. Okay, So again, secondly, they introduce UAV based imagery combined with hybrid matrices. That means for these kind of harsh environments and for these kind of large scale solar projects, we need what we can say a health monitoring system so that we can monitor our whole power plant without any human resource. So this was the objective of the study. What is the motivation? Obviously, as I told, that accurate lifespan prediction, being a world largest power renewable energy company, because we just won the uh, world record of 2024 most bids wind in the field of renewable energy. So we must predict the accurate lifespan of such type of project. Second, optimize and maintenance. uh, the diagnosis is 70% cure for any disease. So obviously, if we analyze and we monitor the solar large scale power plant, then we can maintain it as well, reduce the replacement cost. um, when we monitor accurately, then we will replace the projects or the panels, particularly not projects, sorry, the panels in time, and in time replacements reduces the cost. Reliable energy supply, that means the energy supply should not disrupt as long as the project is installed. So we must supply continuous electricity. So this is also one of the motivations. And improve PV technology. As much as you integrate the AI and the modern techniques in the current technology, so it will also improve. So here are the environmental condition of Dharan, because we took Dharan is a Dharan site which is 13 years old. So we took the samples from there. So we have to analyze the conditions there. Like in summer it's temperature annual value is 27 degrees, and in summers it increases above the 50. So it's harsh condition. And ultraviolet radiation, as it was mentioned before, very high and extreme. And average humidity is 20 to 40 percent. It varies seasonally. So this basically creates the corrosion effect on the solar panels. And annual solar irradiance, that means 2300 kilowatt per meter square. Okay, wind speed 3.6 meter per second annual average. And in dusty and what we can say desert environment, this is a lot air and creates a lot of sandstorms. And dust density high, especially during sandstorm season, because the dust particles here contain some silica particles as well. So it's very uh, dense sort of dust. So here is the methodology overview. What we did, we just took the images of random solar panels. These are the two samples we took for our this little study. These two what we can say images sent to Gulf Renewable Energy Laboratory, GRL, for the baseline performance. This is the one of the largest renewable energy laboratory inside the Middle East. So they gave us some results after evaluating these panels. We will discuss that later. Then what we did, we opted in other method. What we did, we uh, what we can say sent those images in some image processing techniques to see that either the results from GRL and via this method are coming exactly same or not. Second part is to analyze the exact corrosion and cracks on the surface of solar plate, because as mentioned, due to cleaning of the solar panels and the density of the dust and silica particles inside the dust, they create more scratches on the surface of solar panel. That also reduces the um, efficiency. So what here methodologies opted: start, acquire high resolution images. That means we can take the image of any solar panel via a high resolution camera. Then image processing, high histogram equalization and Gaussian blur. These are the famous techniques to what we can say um, apply some grayscale division on it, and apply edge detection techniques. Why we apply these techniques? In order to and then we apply the contrast and refinement in order to detect the cracks. You see here, you can easily find these, the dark black things are the cracks, and these white things are the corrosions that has been what we can say opted by this solar panel. Okay, so after that, we thought that instead of doing what we can say manual photography, what we can do, we can install a microcontroller or programmable chip inside this drone and a high resolution camera, and we give this drone coordinates that you can fly from here to here in order to analyze the images. The drone will take the images and it will perform all the operation of image processing techniques, and then it will send the signal that at this particular part I found this panel is totally damaged or partially damaged or not working, etc. So this was the idea. Then how we compared basically the processed image from our technique, we plotted it here, and this was the image of very fresh PV panel, and we applied exact same techniques on this panel to compare these both plates, that how much deviated or degraded the first panel left side is. Then hybrid technique for degradation quantification combine structural similarity index. This is the method to compare and contrast these two. And pixel intensity difference, PID, definitely. Then SSIM provides a structural degradation score, and PID estimates the discoloration and surface erosion. So this was the hybrid method. Okay, results and visuals. So you can see here in the plates that detected scratches. These black dots are the scratches, and these are the damages. The dense area you are seeing, this plate is basically very much damaged. Okay, and the corrosion is also here. The white part is basically of corrosion. So these are the results we got, and then these are the quantitative results. The SSIM in PID degradation percentage, hybrid metric results degradation ranges from 55% to 75. This is the 55% degraded, and this is 75%. So now here are the graph. Okay, you can see this uh, what we can say SSIM intensity and hybrid. So these method. Okay, the high correlation accuracy 90% with GRL lab results 45 to 60%. So this the correlation what we can say accuracy is 90%, but with GRL lab there is a lot of improvements needed, because the results we got from the GRL laboratory, they are matching like 45% and 65% with this method. So obviously this method needs much improvement in the future. So what is the benefit of drone based imaginary technique? It basically cost efficient, scalable, and non invasiveness. So basically when you fly a drone, you will monitor whole plant with a small scale of time, so that makes it efficient, because it is also a solar charge, and it also reduces the human efforts, and mainly it is more accurate because it's a machine. And potential in predictive maintenance and sustainability of PV system. So this can also predict the maintenance and sustainability. If you maintain the solar project properly, then definitely it will last for a long time. So the conclusion: UAV-based approach assessed PV panels in harsh climate, high resolution aerial imaging, and computer vision identify the effect accuracy 90%. Hybrid. Sorry, I'm running out of time, so I have to make it bit quick. Hybrid SSIM PID metric quantify the degradation 55% to 75%. Key degradation factors: heat, UV radiations, and dust particularly, because we estimated before these kind of sites, we install the projects in Pakistan, in China, in Vietnam, Laos. There we predicted the lifespan of like 19 years plus, but here I'm afraid that these kind of projects will not last more than 17 years due to harsh environment and these kind of things. And UAV inspection offer a scalable non-invasive alternative for timely PV maintenance, future research development, real-time drone-based monitoring with machine learning integration. Then that while the drone flies, it also what we can say predicts and learn about these. Okay, so what are the future recommendation? Integration of predictive analytic, incorporate AI driven predictive models to forecast PV deterioration and schedule the maintenance proactivity. And the second part we can do in this, the self cleaning coating. For example, if the drone finds some plate is not working, it can clean it itself. So there are a lot of future recommendations. So the acknowledgement goes to Power China Huadong Engineering Corporation, in which I am working as a research scientist, and secondly the Gulf Renewable, KKR Energy Research Innovation Center, ERIC. These are the references for our paper, and thank you so much.